Welcome back for round two. So example two is pretty much the same thing as example one. So if you got an example one, then you're good to go. You don't have to worry about doing this with me. You can try it on your own and fast forward to the end of your video and see if you get it right. Otherwise, follow along. Okay, so again, the instructions say to find the value of x and the length of each chord. So same thing as before. Which remember guys, this is the case, the chord case, so where two chords are intersecting inside of a circle. Later on, we'll talk about what happens when things start intersecting outside of the circle. But don't you worry, we'll get there. Okay, so again, my two chords inside of my circle, I'm going to label those so we know that this is a chord-chord relationship. My two chords are A, B, and C, D. Oh man, I'm already excited. Okay, those are my two chords. All right, and remember, if we think back to that Prezi, if I multiply each piece of one chord, it will equal the other chord if I multiply both pieces of that chord. So AE times EC equals DE times EB. All right, let's get going. All right, so I need to find which two segments make up chord AB. So if I multiply those together, it will equal the two segments multiplied together of my other chord. So AB, which two segments make up AB? Yes, my brilliant students, they are AE and EB. So if I'm going to multiply AE to EB. So AE times EB. Okay, and that should equal my other two segments on the other chord multiplied together. So the other two segments on my other chord are CE and ED. So I'm going to multiply those bad boys together. So CE and ED. I've run out of space. Should have started further over. Jeez, Miss Long. But anyways, let's fill in those values. All right, so I'm going to put AE over here so I have more space and ED over there. All right, I'm going to fill in my values, which hopefully I'll have some more space than last time since I didn't plan ahead very well. I was not thinking straight. Jeez, Miss Long, what's wrong with you? Anyway, so AE is 6. E to the B is 5. So 6 times 5 will equal CE, which is X, times ED, that says ED, ED, which is 8. All right, let's get to it. 6 times 5, that will give me a 30. So 30 equals 8 times X, which is 8X. All right, now I just need to get X by itself. So the 8 is secretly multiplying to my X. Okay, which means I'm going to be dividing by 8 on both sides. All right, you know, Miss Long, you know that I like to get my X first, so I'm going to write my X value first and write what it equals on the other side using the symmetric property. Okay, so 8 divided by 8 will cancel and turn to 1. Sorry, my phone's ringing. All right, and 30 over 8, 8 does not go into 30, but it will reduce down. Sorry, guys. I should answer my phone, but I want to finish this video. All right, so anyway, so I'm going to have X equals 30 over 8, which 30 over 8 can be reduced down. What's something that goes into 30 and 8? Well, 2 definitely does. 30 divided by 2, so I'm going to divide both of these bad boys by 2. 30 divided by 2 is 15. And 8 divided by 2 is 4. So X is secretly 15 fourths. All right, let's keep going. So yes, I found X, yes, but we are not done because the problem says to find the value of X and the length of each chord. So now I need to find the length of each chord. Okay, so I'm going to break down each chord into the two segments that make up that chord. Okay, so AB, the two segments that make up AB are AE and EB. So if I add those bad boys together, bam, I'll get AB. So I have AE plus EB. All right, let's get going. Let's fill in these values. All right, so AB equals A to the E is 6 plus e to the b is 5. Which 6 plus 5 is 11. Guess what? AB is donezo. Bam. Almost there. All right, and now we need to break down CD into its two parts. So CD equals which two segments make up CD? It is CE and ED. You guys are geniuses, geniuses. So I'm going to add CE to ED. All right, let's start filling in some values. So CD will equal CE, which is X, and then ED, which is 8. All right, which now that I know X is 15/4, how can I use that to help me find the value of X? I would substitute that value in. You guys are so good at using that substitute word. I'm so proud of you for not trying to drop P-bombs on me. Just irks me when you guys do that. All right, so CD will equal X is now going to transform into 15/4. All right, plus 8. Which guess what, you guys? Since we have a fraction, first of all, fractions are our friends, so we're about to have a blast. But anyways, what do I have to have first in order to add two fractions together? I do have to have a common denominator. So I'm going to write 8/1 so it has a denominator. So what is our common denominator, you guys? Yes, it is. It is 4. You guys always know the answer. Okay, so my common denominator is 4, which means I need to multiply this bad boy by 4/4. Okay, which I'm going to multiply straight across, which I'm trying to squeeze it in because I'm running out of space. Okay, so CD equals 15/4 plus 8 times 4 if I multiply across. 8 times 4 is 32 over 1 times 4, which is 4. Look at that. I have a common denominator now. Whoa, crazy. So now that I have a common denominator, I can actually add these bad boys together. So CD equals 15 plus 32, which that will give me 47 over 4. And I'm trying to think if I can reduce that down. Let's see. Well, the only thing that divides into 4 is 4, 2, and 1, which none of those values divide into 47. Well, 1 does technically, but 2 and 4 definitely don't. So guess what? That problem is also donezo. Look at that. Bam. Donezo. Well, I hope you guys have had fun learning how to deal with chords that intersect inside the circle. The next examples, we're going to have chords and sequence actually intersecting outside of the circle. So get ready for that, you guys. It's going to be awesome.